We're interested to study shortest paths algorithms in directed weighted graph, a graph that looks like this. More specifically, we are interested in the shortest paths from a single source vertex. So what is the shortest path from, say, starting vertex X to all other vertices? Let us first quickly define the problem. That is, what is the shortest path? Say we have a graph like this, and we can represent this graph using G equals VE. So where V is my set of vertices and E is my set of edges. And I will represent the weights in this graph using a function that maps each edge to a real valued number. So all of these edges that we have associated weights with them. So basically this weight matrix is simply a table that maps my edges to a real value. So for each edge, which will be Vi, Vj, a pair here, I will have a corresponding real number here. So all of these numbers are a part of this table. Now say we have a path in this graph, let's say S, T, X, a path that takes you from one vertex to the other vertex. And say we have this path consisting of certain vertices. Say P equals a set of vertices V0, V1, all the way to, let's say, Vk. So we have a path consisting of all of these vertices as the starting, intermediate, and the destination vertex. Then we can simply calculate the weight of this path, Wp, as the sum of all the individual weights of all the edges in this path. So for any vertex Vi minus 1 to another vertex Vi, this weight will give me the weight of any vertex along the path. So if I sum all of these weights, this gives me the weight of this path P. Now there can be multiple paths from V0 to Vk, or say in general I represent V0 using U and Vk using V, then I can say that there can be multiple paths from U to V. And all of these paths will have multiple total path costs. Now we say that a path from U to V has a shortest path weight. Let's say we represent the shortest path weight using del UV. So for all the paths from U to V, the shortest path weight, that is the minimum path cost, is equals to infinite if V is unreachable from U. If V is reachable from U, so say we represent all the paths from U to V, let's say using this sign P, then the cost of this path will be Wp of this path. Now for the path cost to be minimum, what we want is the minimum of all of these possible path costs. So for all possible paths P from U to V, we calculate the path costs, and whichever path cost has the minimum value is the shortest path weight from U to V. So now we define that a shortest path from U to V is defined as the path P that has its weight Wp equals to the minimum path cost possible, del UV.